Hi, everybody. The purpose of this video is to provide some instructions and a walkthrough on the carrying capacity lab. So you want to head on over to lab documents and click on that on Blackboard. And the carrying capacity lab is one of the final labs that we have in the class. Now, the week that you're going to be doing this, you won't quite be covering carrying capacity yet as far as the content goes in the class, but this is a nice preparation for learning about carrying capacity. So the final two labs of the class are simulated methods to estimate population size, and then we have carrying capacity and demographics. So this walkthrough is for carrying capacity and demographics. So when you click on that, it says that you're not going to need any PPE. And just to keep the materials away from children and pets, it does involve having kidney beans and using them as a model for a bird. I know that sounds kind of strange, but believe it or not, this kind of thing is pretty common in biology labs to use beads, to use beans, and to use them as individuals in an ecology lab. So some things that you're going to need, you are going to need 6 sheets of paper. They don't need to be terribly big. You are going to need copies of data table 3, some graph paper if you're going to graph by hand. If you're not going to graph by hand, then you're going to need access to graphing software. So I'm going to go ahead and pull up the background and procedures. And I just want to make sure that this is sharing properly. So when I first went through this lab, I have done other labs similar to this, but not this one in particular. And to be quite honest with you, I found the directions to be confusing. So I really think that, there are going to be some of you out there that after the first read, you're going to think, what is this talking about? So I had to read it a few times and I had to do the lab myself. I do try to do all of our labs to make sure that I'm experiencing it from a student standpoint. So hopefully I've broken the part of this lab that I thought was the most challenging. Hopefully I've broken it up into smaller pieces that you're going to find a little bit more palatable. So you have all this background material on growth rate and exponential growth rate. Obviously, you should always read your background material. So this is going to be important to your understanding of what's going on. And once you get past all that, you are going to see the instructions. Okay. And let's go ahead and go to activity 1. Activity 1 is not difficult. I did include some activity 1 in the walkthrough just so that you could kind of see what's going on here. But activity 1 is not difficult. I personally thought activity 2 was a lot more challenging. So I'm going to go ahead and read a little bit of activity 1 for you and show you what I have as far as some visuals. So you are going to need 6 blank pieces of paper. And on each paper, you're going to write a time down. So it's going to be time equals 0, time equals 1, time equals 2, time equals 3, time equals 4, and time equals 5 on each of the papers. Then you have to count out 5 beans and put them on the paper labeled times 0. And that's your starting population. You're going to assume at first that your population growth rate is 2.0, which means that you're doubling. So every time you're going through an iteration, your population is doubling. So I'm just going to show you the graph, or I'm sorry, the table really quickly that goes along with this. It's your first table. So again, these time intervals are going to be on a piece of paper. You're going to start out with 5. So I'm going to show you, I'm just going to use the annotation tool and write a 5 there. Okay. So then when you go to time 1, so you'll have 5 beans on your paper. When you move them to time 1, which you can move them if you want to move them, or you could just pull out more, you're going to double it. So doubling is going to lead you to 10. Then you're going to go to time 2 And so it has to be double of time 1. So that's going to be this. Now you might be thinking, well, I could do all this without doing the beans, right? Yeah, you could. Mathematically, you could do this, but then, it might help to actually see it as you're going through the other population rates. So this here is fairly simple because you're doubling each time, but then on the others, you're not doubling. So this is, basically going to be your first set of data. Now, in your next one, you're not doubling. So instead of multiplying by a factor of 2, you're going to multiply by a factor of 1.5. And you're going to see what does that bring you. And it tells you in the lab, it says if it gives you a decimal, no matter what the decimal is, round down each time. So because you can't have 9/10 of an individual, you can't have 8/10 of an individual, you can't have 7/10 of an individual. So you have to round down. So here you're going to take it and multiply by a factor of 1.5 each and every time. So from here to here, multiply by 1.5 from here to here. So you're going to be populating numbers in here and coming up with your table. For the next one, it's 0.7. So you're still starting out with 5. You're going to multiply it by 0.7, get your next number. Take this, multiply by 7, and that's not a 0 there. That's meant to be like this is a number, and then multiply that by 0.7. Multiply this number by 0.7, multiply this number by 0.7. So each and every one. And then your last one is multiplying by the number 1. So you start with 5 again, and you're going to multiply by 1 each time. Okay. And when you're done, you're going to come up with this like big spreadsheet. It's going to be a big spreadsheet, and you're going to put it in either Google Sheets or Microsoft Excel. And keep in mind that you should not be putting any words in with the numbers. You can still have your titles in there, but you shouldn't have any words next to your actual numbers. And what you do after that is you highlight your data. So we've gone over this before on how to make a graph. And the graph that you're going to use for this one is, it's going to have several lines in it. It's going to have 4 lines. It's going to have 1 line for this data. It's going to have 1 line for this data. It's going to have 1 line for this data. And it's going to have 1 line for the last data. So each and every time, you want to highlight just your numbers like so. So you would highlight just the numbers. I wouldn't highlight the word time interval. I wouldn't highlight the R's. You're going to highlight just the numbers, and you're going to hit insert graph, and you might have to choose line graph. You should be at the point now. This is like our 11th lab. So you should be at the point now that you are fairly comfortable coming up with a graph, that you're putting it into Google Sheets or Microsoft Excel, or you can still graph by hand. It just needs to be neat. But there should be 4 lines in a single graph. Okay. And each line is representing a different growth rate. Okay, so I'm going to go ahead and clear this out because activity 1 by far is easy compared to activity 2. So let's kind of take a look. Before I move on to activity 2, though, I do want to just show you just show you a couple slides I made here. So just make sure this is sharing properly. Looks like it. Okay. So for activity 1, these are your materials. And I'm just going to use the annotation tool again. And okay, so like you can see on here, it actually says time 0, time 1, time 2, time 3, time 4, time 5. And I have my 5 beans right there. I have my data table up here. I don't need bird bean island map yet. That is activity 2, and that's going to be something else. So then we have my pencil. I always use a pencil. I don't even try to use a pen when I start out with these because too many mistakes. So you want to make sure that you're taking that 5 bean population and changing it. For the first round, it's doubling. So that's where it's going to turn into 10 here and 20 here. But then when your R changes, your multiplication factor changes. So your population is going to change, the next time you run the sample. So like your very first activity, you're going to have 40 here. And you might be like, again, do I have to really count all these out? Sure. I mean, if you're a visual person, go for it. If you're not, and you're like, I don't feel like counting out 160 beans, that's fine. That's fine. You can do it without using the beans. Okay, so let me clear all that out. Yeah, so you can kind of see what I went through here. And then I started filling out my chart. So you need 6 blank pieces of paper. You're going to need to graph it, So activity 1, we're going to consider that, the walkthrough for that is pretty much done. And it's fairly easy. It's activity 2 that is different for sure. Different than I've run it before. So let's take a look at the instructions first before I show you any pictures. Okay, so here's the deal. With activity 2, you have a map and it's called Bird Bean Island. And you're going to be simulating carrying capacity. So in this one, it's different because you're going to take into account birth rate and also death rate. And you have some serious rules that are going on here. So basically, the birds are going to be in pairs. Okay. And when they're in pairs, they can sort of oversee a territory of the island. There are 32 territories on the island, each of which is the minimum space required to raise a single chick to adulthood. A given pair of birds can occupy from 1 to 4 of these territories and will have a corresponding number of offspring. So if the pair is in charge of 4 territories, which is the max, they can't be in charge of any more than 4. If they're in charge of 4 territories, they can have 1 chick per territory. That's just the rule of the game. It's not even a game, but it's the rule of the lab. So if they're in charge of 2 territories, they can have 2 chicks. If they are in charge of 3 territories, they can have 3 chicks. If they're in charge of 1 territory, then just 1 chick. There will be death, and you will follow along a death rate. Your first activity has you at a death rate of 0.1, and then your second activity has you at a death rate of 0.5. So you don't really get to decide the deaths. The deaths are predetermined, and you just use it in a calculation. Okay, so here's kind of where it starts. When you have your breeding pairs and you start to fill up the island with these birds, you'll start to notice that it's going to get crowded over time. And the thing is, you can have a breeding pair and they're allowed to have, in addition to having offspring, they can have a helper come along. So there can be somebody on the island, a bird on the island, that is designated as the couple's helper. And that helper is allowed to be there. So your carrying capacity completely is 96. So 96 beans or 96 birds. Why 96? Because if you take a look here, you can have 32 breeding males, 32 breeding females to go with those males, and then you can have these 32 helpers. So you can have 1 helper per couple. And once you have that 96, like there can't be any other birds on the island. There can't be anything else on the island. So how do we start out? Well, we start out by putting 4 beans on Beanbird Island on the map, just 4. So I'm going to show you how I did that and kind of walk you through what I did. So we have 4 beans on Bird Beat Island, and it says to place them in a center of 4 small territories. This is where I was getting confused because I was like, what do they mean in the center? So this is how I started. Okay. And if you take a look At first, I wasn't sure where the center of a territory was. I was like, what is it talking about, the center of a territory? But now it kind of makes sense. Like if they can be in charge of 4 territories, put them in the center so that they're kind of touching the 4 territories. I picked these 4. You don't have to pick those 4. And then I picked these other 4 down here. So like I've, this is a territory, territory, territory. If you look, all the territories are kind of in 4 clusters. But I put my 2 birds here in the center of these 4. Okay, so that's how I started out. Now, I'll show you where I went from there. This is the initial setup. You could put yours in a different spot, but this is where I put mine. All right, so then they had to have offspring, and they are allowed to have 1 offspring per territory that they're in charge of. So these 2 mating couples, I put them in the center of 4 territories. So they are in charge of these 4 territories. So this couple is in charge of these 4, right? And then this couple is in charge of these 4. Kind of looks like a clover. So I was allowed to put 1 offspring, which there's 1 here, 1 here. I was allowed to put 1 offspring per territory, right? Like there it goes. And we'll talk about filling out the chart in a minute, but that was how I started it. Okay, you might start a little bit differently, but that's how I started, that they had their 4. So I'm going to clear out those drawings and then I'm going to show you what I did next. Basically, it tells you once they have offspring that birds, when they reach their maturity, they're going to want to redistribute into couples. So I had to redistribute them into couples again and make them in charge of territories. So I had to take the offspring and the parents from before, right? I couldn't have any more than that or any less than that. So I have this couple in charge of 4 territories, this couple in charge of 4 territories. This couple, it looks like they're only in charge of 3 because they're kind of in the center of the 3. The other territory is right here. And I wouldn't necessarily say that that's close enough, so I just said that this couple that I just circled was in charge of the 3. This one's in charge of 4. This one's in charge of 4. And this one here, I made them in charge of the 4, even though they're kind of close to the 3 as well. But I said, okay, they're in charge of this one, this one, this one, and then there's one off the screen that you can't see. So that was my redistribution of the couples. And as you can imagine, once you redistribute them, they have to breed again. So I'll show you what that looked like. Let me get this off of here. Okay. All right. So this is what I got from the breeding. So take a look. Remember, you can only put 1 offspring in every territory. So here's offspring number 1 for this couple, 2, 3, 4. The couple's still in the middle. The 4 offspring are surrounding them. This couple over here, I just said that they had 3 because I felt like the other circle was kind of far away for them to be in charge of. This couple has 4 surrounding it. You can see them, right? So we're starting to fill up the island. That's the point here, is that I don't have any helpers instituted at this time. I figured I would start instituting helpers when I was getting closer to carrying capacity and when I really had to institute helpers. So you can see that every couple here, I guess I did just do 3 for these, just 3 offspring. I didn't put any in this one because I felt like it was kind of far away. So this is on your data table. If you take a look at your data table, this would be time interval 1 because I already had them breed. And now, now the next generation is having birds. So this would be time interval 1. Okay. I'll show you what that looks like, the table, in just a second. Okay. So before I go to the next step, I want you to think in your head, what would be the next step after this? They all just had offspring. So what did I do the last time that they all had offspring? Give yourself a second. Think about it. Okay. If you said that I need to redistribute the beans, you're correct. The offspring would grow up and then they would want to go mate. So let's see that. And there we go. Now you'll notice this time around, I'll tell you a difference that I had. I have a bean right here that was like the odd man out. So every bean on the screen has a mate except for one. So what I did is I was like, okay, that's going to be my first helper. So this is the helper of this couple because it was just left over. And the reason why it was left over is because after time interval 1, I had to apply the death rate. And when I applied the death rate, somebody died. So remember, you're taking, and your lab actually tells you how to apply the death rate. So once I applied the death rate, like, you know, so a bird died and you have to remove it from the population. So this guy, you know, whoever its mate was gone, died. So that's why I just made this one the helper. Okay. So it says after time interval 1, it was time to redistribute into breeding pairs for time interval 2. So this is time interval 2. You would be on like the third row of the chart. And now they're going to mate. But take a look here. When these mate, it's going to be a little less than the past. So if you tried to predict here, like let's say this couple had 1 and this couple had 1 and this couple had 1. You might be able to say that one of these couples had 1 in this circle as well, but you don't have to. You could say that this couple had 1 here, this couple had 1 here, this couple had 1 here. So it's kind of up to you. Like you'll see how I did the beans at this point, but you know, you could have, as long as the bean couple is in charge of a territory, it's going to have an offspring in that territory. So remember, you can only have 1 offspring per circle. But you could say like, okay, well, what if this couple was in charge of this territory and this territory over here? You could probably say that. You could probably say that. I don't see any strict rules saying that you can't say that. So this would be your prediction for the offspring that they're going to have. Okay. Now, I think at this point in time when I took these pictures, I think this is when either my kids or my dog came in the room and shook the table. So, word to the wise, you want to do this far away from children and far away from pets because my map didn't come super flat. And then when I'm putting the beans on it, it's like rolling around. And then if anybody like shook the room or ran too fast or whatever, the beans were just shaking all over the place. So save yourself some frustration there. All right, let's take a look and see what the next slide looks like. Okay, so here you have it. It says during time interval 2, some breeding happened. And this is the breeding. So again, it's going to kind of be up to you, like, you know, where you want all the offspring to go. But all the singles here are offspring, like offspring, offspring, offspring. I'm circling all the offspring. Even the couple over here that had the helper that had an offspring. So, you know, just take a look here and you can see that there's offspring in certain spots. And it's wherever there was a breeding couple. And this whole time, you're filling this stuff out in your chart. Okay, so, and then there's a lot more, but I'm not going to sit here and circle every single one, but you should get the idea by now. So you'd have to ask yourself, okay, now that the breeding happened, what would be the next step? What would be the next step? The next step would be redistributing the pairs. Okay, so you would need to redistribute the pairs. So I'm going to clear out these drawings and then we're going to talk about what you should actually fill out in your chart. And of course, your data is going to be tailored to whatever you're doing, but I'm going to show you how I filled mine out. Okay, so just to show you what that redistribution would look like, Before we go to the chart, these are the redistributions that would start time interval 3. And it says, I am at 26 breeding pairs. Now, if you happen to count on this screen and you don't see 26, it's probably because of the situation that happened with my kids or my dog. But it's close to 26. It's close to 26. You do have a single here. Okay, I had a single. And what happened with that single is you could actually use it to be a helper. So I probably would have done that. I probably would have just pushed it over to a couple and made them a helper. I don't know, now that I'm looking at this, I'm not sure why I have 2 couples here. That shouldn't be allowed. So I would probably need to redistribute this bean over here to be a helper. And then this bean, I could probably couple this other bean with, the guy down here, something like that. So there should be 26 pairs here, but there is an error because you can't have 2 couples on a circle. And you should try to be making pairs whenever you can. But take a look. I mean, I don't have too many circles left. I have this territory left, this territory left. I mean, there's only very few territories that don't have a breeding pair supervising it. So you can see that I'm starting to reach carrying capacity. Okay, let's move on to that chart. Okay, so I'm just going to show you some sample data that I had. I think I'll keep my font on red so you can see it. But basically your number of breeding pairs, if you have 4 individuals in a population, your number of breeding pairs is going to be 2 because you have 2 pairs. 2 pairs is 4. Now, when I did it, my number of offspring, I gave them 4 offspring apiece. If you go back to one of my very first slides of this activity, you'll see that I gave them, the couples, 4 offspring apiece. So that means that there was 8 offspring. To calculate birth rate, it gives you the equation in your, in your lab instructions. And my birth rate there was 4. Your death rate is up here, right? It gives you your death rate. So you have to multiply that by how many individuals you had. And if it doesn't hit the number 1, it's automatically a 0. So for me, it was a 0. Number driven off, you can look in your lab and see how that's calculated. I didn't go over carrying capacity. So if you go over 96, you're going to drive birds off the island because they can't stay. I'm not over 96 at this time period, so mine would be 0. And then your population growth rate, it gives you how to calculate that. And for me, that was 3.0. So the population growth rate, so your population growth rate is going to be your individuals that you have for the next population. So if you take a look, I had an initial of 4. I had 8 offspring. Those 2 together are going to give me 12 for the new population. So it's your new population divided by your old population. So the way I got 3 here was I took my 12, which is going to be my new population, and divided it by my old population, which was 4. So once I had my 12, if I separate that into breeding pairs, that's 6. And the number of offspring, if you go back to my pictures, the number of offspring I made for them was 22. And you can go back and look at my picture for that to kind of figure out how did I get 22. But I did get 22. And if you calculate birth rate for that, and again, the lab tells you how to calculate birth rate, I got 3.7. As far as my number of deaths, I still had to apply my 0.1 for number of deaths. And this time I had 1 death. That was the one that I mentioned earlier. I didn't overcome carrying capacity, so nobody was driven off. And if I take a look, I need to add my original population plus my offspring. So if I just use like a little bit different, I don't know if you can see, I'm using yellow here. Let me try a green. So I'd have to add my 12 and my 22 to figure out my new population, but I have to subtract my 1, right? Like I have to add 12 plus 22. This is getting sloppy, sorry. But then I need to subtract the 1 from it to get my new population, and my new population should be 33. So if I take 33 and divide that by my original population for this line, which was 12, then my growth rate is 2.8. Yours might be different, and that's okay. It depends on how many offspring you choose for the birds to have. When I had 33 at time interval 2, my breeding pairs was 16. That's why I had that odd man out. And I said that I was just going to make that bird a helper. The number of offspring that I produced during that time frame was 23. And using the birth rate calculation provided in the lab, I calculated a 1.4. Now, the number of deaths this time, I'm still applying this 0.1. The number of deaths is going to be about 3. I did not exceed carrying capacity, so that's a 0. And then this time, I would take the 33, add it to the 23, that's going to be 55, but I have to subtract these 3. I'm sorry, it's not going to be 55. It was going to be 56, but I would subtract these 3, and that's going to give me 53 for my new population. And to calculate my population growth rate from before, I'm going to take that 53 and divide by 33. And that should give me a 1.6. So you can see where you're going to just keep filling out the numbers here. So for my next one, I would calculate breeding pairs. Now, as you start to get up to 96, once you get over 96, you're going to use this number driven off, because you're going to drive birds off the island. There's not going to be enough space. The lab does say that you need to continue this until you have 3 generations of a steady rate, of the same rate. So I'm going to go back into the lab where it actually says that, so you can see what your end game is. So I'm back in the lab instructions right now, and it does say how to end that activity. So it says that you're going to repeat the iterations until the population of bean birds remains unchanged for 3 consecutive time intervals. So the population is going to remain unchanged. So once you get to the point that your beginning number, your N, is 96, you're not going to be able to do much because you're at carrying capacity. Okay. Once you get done with that activity, you will then do the same activity, but with a death rate of 0.5. So with a death rate of 0.5, it's gonna be a game changer. And then it wants you to graph the results of the 2 simulations and note the differences over time between a death rate of 0.1 and a death rate of 0.5. So you're going to plot 2 lines on the same graph, and remember to label your axes and title your graph. So you're basically plotting the the death rate. Like you're going to have 2 lines for death rate. So if you take a look back at the instructions for the lab, it tells you exactly how to label your X and Y axes. So let's take a look at that real quick. So right here at your deliverable, at your turn in button for the carrying capacity, it does tell you um, for the activity that we just saw, you're going to fill out the data tables, and then that you're also going to create what's called figure 2. Figure 2 is a line graph that has 2 lines, one for each simulation from tables 2A and 2B. Your y-axis is going to be your rate of population growth, and then your x-axis is going to be time. So you should be able to put 2 lines on one graph. One line is going to be from when the death rate was 0.1, and one line is going to be from when the death rate was 0.5. Okay, so make sure you're taking a look at your axes there and that it's labeling correctly. No matter if you're using Google Sheets or Microsoft Excel, the rate of population growth should be on the y-axis, time should be on the x-axis, and you should have data for death rate of 0.1 and death rate of 0.5. Okay, so you can do that also by hand, but you should be using graphing paper. Okay, so I hope you find that helpful in order to figure out how to do that part of the lab. The other parts of the lab I don't think are that confusing. But if you do struggle with any other portion of the lab, please feel free to reach out with me. But I did feel compelled to make some sort of visual tool for you to use for this part because I thought that with so many different steps to it, that it was confusing. So I hope that helps. And please contact me if you have any further questions.